We are continuing on with our notes by adding vectors algebraically. So kind of how I talked about before, drawing our vectors to scale is just not a great use of our time, and we can be more effective and efficient if we just use math. So looking at these three situations we have here, the first set of vectors that we have that we'd be adding together are perpendicular, okay, and because they're perpendicular, we know that they come together at a 90-degree angle. Okay, for the second two vectors that we're adding, okay, we'll call this angle theta because it's unknown. We know that it does not equal 90 degrees, so these are non-perpendicular. Vectors. We'll talk about ways that we can solve for those. Okay, and then lastly, we have adding three or more vectors. All right, to start, we're going to talk about adding perpendicular vectors. Okay, so when we have two vectors that are added together, and their directions are perpendicular, meaning like one is north and then one is east or west, we can use Pythagorean theorem and the trig ratios. We'll kind of go through an example problem of how to use those. Okay, so the big thing is just remember that any vector must include both magnitude, which we can use Pythagorean theorem to solve for, and it must also have direction. And we'll use the trig ratios in order to discover what the direction of the vector, the resulting vector is. Okay, so let's just do an example. So Neil walks 1,500 meters north, then 750 meters west from the planetarium. Find his total displacement. Okay, so I'm going to start by just drawing a diagram of what's happening here. So first he starts 1,500 meters north. Okay, and then he goes 750 meters west, okay? And we don't have to pay attention to if this is to scale because we're going to be using math in order to calculate our result, okay? So our resulting total displacement would be this vector, okay? So we're going to call this our total displacement. So I'm going to give it a subscript of t for total displacement. All right. So because this is running north and west, we do have a perpendicular 90-degree angle. And so we can use Pythagorean theorem. Okay. So remember that Pythagorean theorem is a squared plus b squared equals c squared. So we'll make this side A, this side B, and this side C. All right, so we're going to have 750 meters squared plus 1,500 meters squared equals c squared. And I'm just going to keep it c squared just to have less letters to represent the displacement. Okay, so whenever I take the square of each of these and then add them together, I get 2,812,500 meters squared equals c squared. Take the square root of both sides, and we should get c to equal 1,677 meters. And I rounded there. Okay, so that is our, so this is our delta D. So displacement, total displacement. All right, so now we have to find the direction, okay? So we went north and then we went west, okay? So in order to do these, we're going to use the trig ratios. So you probably remember this from math class, but we're going to use SOHCAHTOA. Okay, and the known values that we had for our angle, okay, because the angle we're trying to find is this one, okay, because that was the direction that we went. So we'll call this theta because it's unknown angle. Okay, the known values that we have is we have this one, which is the opposite side, and then we also have the adjacent side. So we're going to be using tangent in order to solve for this. So tangent of theta equals 750 meters over our adjacent side, which is 1,500 meters. Okay, and when we calculate this out, we get that theta equals 26.6 degrees. Okay, we'll just round it to 27 in our answer. Okay, so writing our final answer, we get that the total displacement is, first we write our magnitude, so 1,677 meters. And then to write our direction from north, okay, we went 27 degrees west. So Erwin carries his cat around for a walk. Erwin walks 25 meters west, 15 degrees north, then 110 meters south, 40 degrees east. Find Erwin's total displacement. So we're going to start by kind of just sketching out his path. So first he went west 15 degrees north, and that was 25 meters. Okay, and in order to figure out the angle, so it's west, so let's go ahead and just kind of dash in our western compass line, and then it was north 15 degrees, so this angle here is going to be 15 degrees. Okay, and then he walked and I'm going to kind of extend this out a bit just so I can get kind of past the 15 degrees that I have drawn in there. Okay, and then he's going to walk 110 meters. So let's just say it was that way. And then our angle from south is 40 degrees east. So we're wanting to find what is the result displacement. Okay, so this is what we're trying to find is the displacement total, and then the angle that we're going to find our direction would be here. So this is our theta that we're trying to solve for. So we do have two of the sides of our triangle, okay, but we need to have a full angle in order to use our cosine law. Okay, so one thing though is that we do know that if we had a parallel line here, okay, that went out east basically from that southern point, that this would create, let me highlight it, this would create a 90-degree angle. Okay, so that's a 90-degree angle here. Okay, So we can, because we have a parallel line here, so we have a parallel line here, and then a parallel line here. Okay, and then we have a line that's intersecting them. We can use our angle rules to know that if this is 15 degrees, then this angle is going to be 15 degrees as well. Okay, because they're congruent. All right, so for this purple 90-degree angle we know that it's 90 degrees. Okay, and we have, so far we have 40 degrees plus our unknown, let's call it beta. So we'll call it beta plus 15 degrees. So we can find what that beta angle is, and we should find that beta is 35 degrees. Okay? So now we know that that is 35 degrees. So now we have two sides of our triangle and an angle, so we can use cosine, or cosine law. Okay, so we discovered what the angle is, and so the side opposite the angle, in order for us to use our cosine law, is going to be RC. So this is going to be C, side C. Okay, so then we'll make this side A and this side B. So whenever we plug in the equation, so here's our equation. We're going to have C, which is our delta dt. So I'm just going to still leave it as C just for simplicity. So C equals the square root. So C equals the square root of our A squared, so 25 meters squared, plus B squared, so 110 meters squared, minus 2 times A times B times the cosine of our beta, or of our angle, which is 35. Okay, so when we go ahead and plug all of that into the calculator, we should get that our C, which is our change in position, our total change in position, is 90.66 meters. Okay, so now we need to find our angle beta, or not beta, theta, in order to give direction, because now we have the magnitude, but we need to find direction. All right, now we need to use the sine laws in order to solve for our theta. Okay, so theta is part of a larger angle. So far in that portion of the angle, okay, so it's this total angle right here. So for that angle, we know that this portion right here is 90 degrees. Okay, so we know 15 plus 90 degrees plus theta equals that total angle. Okay, so we need to find that total angle so that we can solve for theta. Okay, so the angles that we do have inside of the triangle already is our beta, which is 35 degrees, which correlates with side C, which we calculated as 90.66. Okay, and then we want to know what is this angle B. The green angle would be angle B, lowercase b. And we have side of B. So we're going to use sine of B over B equals sine of C over C. So sine of B over, so we make this big B, and this should be a little b. Sine of B over 110 equals sine of our angle C, which is 35, over our side C, which we calculated to be 90.66. Okay, so we're going to get that the sine of B is equal to 110 times the sine of 35, all divided by 90.66. We get that our B angle is 44 degrees. Okay, which doesn't make sense for this problem. So it is an ambiguous case. So we actually need to take, in order to find our theta, or in order to find the whole angle, 180 minus the 44 degrees. So we should get that angle B is equal to 136 degrees. And then, so if we know that angle B is 136, then we have 15 degrees plus 90 degrees plus theta. We can solve for theta, and we should find that theta is 31 degrees. Okay, so our final answer is going to be 91, we'll go ahead and round it, 91 meters, and it's south 31 degrees, and then it moves east.